Hey everybody, it is video 1.3.3. That is the first unit. It is the third standard and it is the third unit or third video. Woo! All right, unit 1, standard 3, video 3. We're going to be solving between statement inequalities. But first, we're going to make sure we have our materials. Are you in a quiet place? Do you have your headphones on? Do you have your notebook and pencil and pencil? Pencil and pencil? Pen or pencil? You don't need both. And are you ready to watch? If so, let's go, and don't forget to pause wherever you need it. Here's the title of our lesson again, Solving Between Statement Inequalities. You do want to write that down so that you can reference this later. Let's get going. All right, we got 3 examples. This is our first one. And I love using the inverse operations methods, but in this case, this really don't work so well that way. We definitely could do it, and I can show you if you're interested. But I'm going to go ahead and just solve this a little bit more straightforward. Because this is a between statement, that means that I actually have 2 different inequalities going on at once. So when we have that idea that whatever we do to one side of the equation, we have to do to the other. Well, there's really technically 3 sides of this inequality. If you don't believe me, I can break it up, and we could say a negative 7 is less than 2x plus 3, but 2x plus 3 is less than or equal to 5. So if I were to subtract 3 from both sides and use our inverse operations here, what you would see is that I have to move 3 from the negative 7 and I have to subtract 3 from the 5. So here's how we're going to do it. I'm going to get rid of all of that. You may do it this way though, that's fine. And I'm going to just subtract 3 from all 3 places. Rather than both sides, I have to use all sides. That leaves me with a negative 10 less than 2x less than or equal to positive 2. Once again, if I'm going to divide by 2, I have to do it in all areas. So I divide by 2, divide by 2, divide by 2, leaving me with negative 5 is less than x is less than or equal to 1. Well, there's our inequality representation. Let's go ahead and put this on a number line. When I put a between statement on a number line, it's already giving me the 2 ends. It's telling me that from negative 5 up to positive 1, these are the places we're discussing. We are between those 2 values. Remember, it's a between statement, which is an and, which means it's an intersection, which means there's overlap. So I have an open circle because we're exclusive with negative 5, and I have a closed circle because we're inclusive with positive 1. And where is x? It's between. So there's our inequality, there's our graph. Our interval notation goes from negative 5 to positive 1, and we show that with a hard bracket that it is included. It's inclusive. Let's try another one. Let's just go straight to using the method where I move it out from the middle. So I'm going to add 1, and I have 5 is less than 3 halves x is less than 9. Well, just as before, I have the x in the middle, and I have to get rid of its coefficient, the 3 halves. To do that, I'm going to multiply everything by 2/3. So I multiply this by 2/3, and I multiply this one by 2/3. That's multiplication there. When you multiply 2/3 times 5, you get 10/3. And we're going to leave it as an improper fraction right now. Less than or equal to x, less than or equal to, this one does reduce, 6. On your number line, I've got 10/3 and I've got 6. They're both exclusive, and where is x? It is between. Using interval notation, they're both parentheses because they're both exclusive, and it goes from 10/3 to 6. I've got one more for us to try. All right, I see something a little bit different. It's what's in the middle. It's my x. My x is negative. I have a negative 2 for my coefficient. But let's try it anyways. I'm going to start by subtracting the 3. That leaves me with negative 8 is less than negative 2x is less than 8. I have to divide everything by negative 2. Remember, when we divide by negative 2, we also flip the inequality symbol, which means I have 4 is greater than x is greater than negative 4. Now, this is an okay way of writing it, but there's a better way of writing it. Actually, it's the best way to write it. And that means flip the entire thing over. Now, why do we do this? Because it goes on our number line that way, because it goes in our interval notation that way. It communicates everything in the same order, which means I have negative 4 is less than x is less than positive 4. Now, I didn't just flip my symbols twice, I just turned the inequality around. This was when I flipped the symbols because I divided by a negative. This was just to put it in the right order. All right, on your number line, we go from negative 4 to positive 4. They're both exclusive, and we shade in the middle. Using interval notation, negative 4 to positive 4, soft brackets on both because they're both exclusive. Make sure you go back and rewatch any parts of this video that you need to, and then try the entrance slip on Schoology.